All right, part E, graphing logs. So this time we're graphing some log functions. So here's our example. We have log base 3 of x. In order to type that in my calculator, I want to write it as a change of base, meaning, remember our calculator can only use base 10 if we have a little bit older calculator. So I do that by writing this log like a big fraction. Remember, the base goes on the bottom. So on top I would have log of x. On the bottom, I would have log of 3. So when I type that into my calculator so I can graph it, log button is down by the 7. So I'm going to type log of x, close parentheses, divided by log of 3, close parentheses. Click graph. So again, our graphing calculator does a bad job of showing you this graph. From Desmos, we've seen that it actually does continue going down. Right here, it's just so close to the y-axis, the calculator has a hard time showing you both pieces, so it looks like it stops, but we have to be smarter than that and know that it doesn't really stop. It's just hard to see it from here. I'm going to fill in my table. So I want values from -1 to 4. So it looks like at -1 I get an error. 0 I have an error. And then 1 I get 0. 0.6309, 1, and then 4, 1.2619. So I'll plot those. Obviously I can't plot the errors, okay, but I can plot the rest of my points. So x is 1, y is 0, x is 2, get about here, 3, 1, right there. A little bit like that. Now use your graph to help you connect the dots here. Okay. So it's actually going up just very slowly, and then I know that this side is going down and getting closer and closer to the y-axis. Okay, so because it's getting closer and not quite touching the y-axis, that's why these are errors. So I would, if I had decimals like 0.5, I could have an answer, but for 0, I get an error. So for a log function, I have a vertical asymptote. I can see that on my graph here. And I can tell by these errors that that happens at 0. That's where it starts. So my vertical asymptote is an x equals equation. X equals 0. My domain is where the problem lies with log graphs. I can see there's nothing on the left side here. So that affects my domain. My domain doesn't start until 0, not including 0. That's why it's a parentheses. But then my function goes to the right, so I cover all of those x values to infinity. Range is from the bottom to the top, looking at the y values. So for most log functions, your range is all numbers, -infinity to infinity, because it goes from the bottom. And this is going to keep going up forever, just very, very slowly. But eventually I'll get to all positive y values. My x-intercept, where I cross the x-axis, I see that happens at 1. My y-intercept, I get an error when x is 0, and my graph is showing me I'm not going to actually touch the y-axis, so I have no y-intercept. And lastly, my end behavior. As x goes to infinity, that means look on the right side of your graph. This function, it looks flat here, it's really not flat. Desmos, again, does a good job. You can zoom out and see that this is going up just super, super slowly. So this actually is going to go to infinity on the right side. Now the left side, notice, this looks different than other end behaviors. Here we have x is going to 0. It doesn't make sense to write x goes to -infinity because there's nothing happening on the left side. So the closest it can get to is 0. So as x gets closer to 0, what is the graph doing? Well, the graph's going down to -infinity.